Hey, today we're going to be hacking this Riverbed Steelhead WAN Optimization device and turning it into a 6-port router, all without any soldering and for under $75.01. Everything that I mentioned in this video will have links in the description below. This device comes with a 160 gigabyte SSD and 4 gigabytes of RAM. I was lucky enough to find one on eBay for $75, but although it's great value for a sturdy piece of hardware, keep in mind it runs on 32-bit architecture. This means you won't be able to run the latest pfSense, since pfSense moved to exclusively 64-bit releases since version 2.4. So if you want the latest software, you'll need to grab different hardware. Here's a list of 64-bit versions of Steelhead I found online. The first thing we need to do is download a pfSense image. I'm using version 2.3.5. Next, we copy the image onto a USB drive. I used Rufus to do this. Once that is done, you will need an RS-232 DB9 serial cable, and unless you have a computer from the 1990s, you will also need a serial to USB converter cable. So the reason why you might want to use a device like this is because they've got a very rugged construction. They're made for this purpose to be used inside a server cabinet, for example. It's a 1RU ears you can get put onto this as well, and you can rack mount this inside a cabinet. Another reason why you might want to use something like this is if you need multiple ports in your router. So there's 6 ports in total over here. There's 2 normal interface ports, there's a primary and the auxiliary, and then there's 2 pairs of empath ports. We're going to turn these empath ports into just normal ports, and so then you'll have all 6 of them available to you. In 2016, I hacked one of these devices, but the only way I knew how to was by desoldering a few bits, adding an Arduino fan speed controller, and a few other hacky things. The project was documented on my blog, and I received a lot of feedback from the community, including on how to do it better. So this time around, I plan to hack this same Steelhead device, but without any soldering and without an Arduino. So let's get started. At this point, you've downloaded pfSense, the version that you like, and you've put that onto a USB drive and you've plugged it into the front of the Riverbed device. Just use a console viewer. I'm using PuTTY here. Use baud rate 9600 and reboot the Steelhead machine. Once you get this page, hit delete. Just keep hitting delete until eventually you're prompted for the password. There we go. Don't bother typing the password in that first time because you've got a lot of delete characters in there. Just press enter. Then type in MINNOW, MINNOW, all in caps, and you should drop into the BIOS. The first thing we'll do is we'll press the right key, the right arrow, all the way to security settings. Come down and change the cmos security to disabled. You'll then get an option that says change supervisor password. Go into that and press enter on an empty password. It'll say password uninstalled. That's it, the security portion is done. Then press the left arrow, go to the boot menu. There's only one option here, it says boot settings configuration. Click on that and go all the way down to USB to DOM boot only. That's an option that says only ever boot from the USB that's built inside the machine. We want to disable that, and once you press escape, you'll notice there's a few extra boot options. Go down to USB drives. The first drive, press enter on that. You'll notice there's 2 drives. The ATP eUSB is the one that's built into the machine, and whatever else is shown to you is going to be your USB. In my case, it's just called generic storage device. Select that for first drive, then go to the second drive and disable. Press escape. Go up to boot device priority and just make sure that it's the generic storage device or the other non-ATP eUSB device at the very top there. Press escape. Go left again to the advanced menu and go to IDE configuration. Go down to configure SATA as and change that to IDE. You notice the primary IDE master you'll notice there's no disks there at all. We're expecting the primary IDE master to be a disk. I'll explain why that happens a little bit later, or how to avoid that. Go all the way to the right, save changes and exit, press OK on that. Now we're going to wait for it to boot up. It's booting up now. If we just wait, you'll notice it actually goes to this menu, press any key to continue. It goes and it tries to boot the internal USB anyway, which is not what we want. And so reboot again. So I pulled out the power, plugged it back in, and just keep pressing delete at the beginning here. Get back into the BIOS and go back to boot. Go down to USB drives again. You'll notice it's gone back to the internal USB. Change it again, and that second drive, disable it again. For some reason you have to do this twice. Make sure that the boot device that is being booted is your USB. That looks fine to me. Now if I go back across to advanced, go down to IDE configuration, you'll notice my hard disk is now showing under primary IDE master. That's what you want to see. So at this point, if we save and exit, it should boot into our pfSense USB installer. But you want to stay on this baud rate for a little bit longer just to make sure it's doing that. The way that you can make sure is that you'll see some funny characters starting to come up. As soon as you see that, you immediately have to go into 11500 baud rate as quickly as possible. There we go, we see it. So I've got a window already open, ready with the 11500 baud rate, and I just pressed open on it and it went straight into this window. The reason why you want to do it as quickly as possible is because this page is drawn fairly early in the point where it changes the baud rate from 9600 to 11500, and it's got a little prompt at the bottom that you don't see anymore. It said something like press spacebar to pause, and it had a countdown of 5 seconds or so, and so I pressed spacebar already and we've paused on this menu screen. If you only see the line that says press spacebar to pause, that means you've missed the point where it draws this. You can still press spacebar and it'll still wait on this little prompt at the bottom here, but you just won't see this menu. So just knowing what you need to press will still work, and what you do need to press is S to drop into single user mode. So I'm going to press S now, and it's going to boot into single user mode and drop me into a shell. When prompted for a shell, just press enter to drop into the default bin sh. And then you're going to run the mount command to mount root as read write. And then using vi, you're going to get into boot loader.conf.local file. Go down to the first free line, press I so you can insert a line. Now at this point I've tested a few of these commands, and the one that I'm going to use, I'll show you. We need to disable cache write on the disk for the disk, otherwise the installation fails. In order to disable cache writing, it says over here pfSense 2.2 and later use this inside that that config file. However, I've used that and for some reason it didn't work. Using this one, which is supposed to be for pfSense 2.1 and earlier, actually works. So your mileage may vary. I'll put the link for this page in the description below, but I'm just going to put that in there. Press escape, then use :WQ to write and quit, and then reboot the machine. You don't need to change your baud rate at this point. Rebooting should get you straight back into the menu that we saw earlier. You just simply miss seeing the BIOS loading screen, but we don't need to go there anyway. This time at this menu you can press enter to boot normally. Don't worry too much about these errors that you're seeing here. They're nothing to worry about. At this point you can wait for the timeout to complete, or you can just press the I key and get into the installer. Accept these settings. For me, I'm just going to do a quick easy install. That just simply means that we're going to delete everything off this disk. I'm happy with that. and off we go. Finally, you get to this option where it asks which kernel you want to install. Install the embedded kernel. There's going to be no VGA port on this machine, and nor are you going to plug a keyboard into it. The only way you're going to access the machine is over IP. Finally, it's installed. It's asking you to reboot. Hit the reboot button. Once you notice that it's rebooting, you can pull out the USB drive. And keep in mind the default username and password is shown over here. So I've pulled out the USB drive now. At this point, there's a pretty good chance that your boot settings have been changed. And if you go back to the baud rate of 9600 like I have done here, you'll notice it's booting back into the Riverbed operating system. So just pull out the power again, plug it back in, and get back into the BIOS. Okay, we'll go back to the boot menu, go to USB drives, there's that ATP again, disable it, check the boot device priority. First one should be SATA, second one we're going to disable it. Okay, save changes and exit. I'm going to leave it on baud rate 9600 just so we can make sure that it does try to boot the right image on the disk. But on the side here, I'm going to prepare another console session with the speed of 11.5200. Once I notice that the funny characters come up, I'm going to close this one down and go straight to the other one. There we go, there they are. So let's close that, open this other one, and sure enough, it's booting onto the disk. Again, don't worry too much about that 512 megabyte, what seems to be an issue. You'll notice, I'll show you a bit later on why it's a non-issue. Okay, once we fall into the menu, the main menu of pfSense, hit number 8 to go into the shell. You can type in sysctl hw.physmem, so physical memory. You'll notice that we do have the full 4 gigabytes here. If you wanted to be absolutely certain, you could even do a cat of var log dmessage, which is not there, dmessage.boot, that's why. And if you go to the top, it should be one of the first things that it says. There we go, available memory, about 4 gigabytes. While we're in here, we need to make sure that the boot option that we put in earlier persists. So we're going to do vi/boot loader.conf.local, and once again paste that in, escape, and write that to disk. We just have to make sure that it sticks from this point on. Okay, that's done. Now the next thing we need to do is control the fan speeds. To fix the noisy fan problem, it's fairly straightforward. Just reboot the machine, open up another console window, but this time with baud rate of 9600, and press delete to get back into the BIOS. I've already done this here. Go across to advanced and go down to hardware health configuration, and you'll notice there's an option that says minimum PWM duty cycle. This is the minimum speed that the fans will run at regardless of whatever the temperature is inside. The minimum speed is roughly about 6,500 RPM, even though the machine is running fairly cool at the moment. It's not too bad. So I'm going to change the minimum PWM to 60. And that will give me roughly about 1,000 RPM. If you're in an environment that needs to be quieter, you could go lower, but I'm quite happy with 60. Then press escape, go across to exit, and save change it as an exit, and you'll notice the change in fan speed is almost instantaneous. And there we go. Peace and quiet. And now the next thing that we need to do is figure out how to enable all of the empath interfaces to be used as normal physical interfaces. Before we enable the empath interfaces, we need to make sure that the two interfaces that we know are working are set up correctly, and those are the primary and the auxiliary interfaces. Plug in network cables into both of these interfaces and make sure that the link lights come up. Then come back to the screen that you see in front of you, and you'll notice that EM0 and EM1 are configured as the WAN and the LAN interfaces. This is wrong. We need to change this, and before we do, we'll just check to make sure that we have all 6 interfaces showing. So we'll press number 8, go into the shell, type in ipconfig. I'll just expand this up a little, and you'll notice that we have 1, 2, 3, 4, 5, and 6 interfaces. The ones that say no carrier are the empath interfaces, and the 2 that we have got plugged in with link lights should show up here as status active, and those are the EM4 and EM5. Now, from my own testing, I've found that EM5 is the auxiliary interface and EM4 is the primary interface. So we're going to exit, and in my case I'm just going to set up EM5 will be my WAN and EM4 will be my LAN. And that's it, I'm done for now. I'll press yes and it should configure those interfaces. Okay, now that the interfaces are up, you can see that EM5 is my WAN, EM4 is my LAN, and I can double check that if I like. I can drop into shell. I've got a ping running from my machine to the LAN interface EM4, and so I can do a TCP dump and check that those pings are indeed coming in. And sure enough, you can see those pings are coming from my machine, which is .10. Excellent. Now we can enable those 4 empath interfaces. We're almost ready to enable the 4 physical interfaces. But first, let's talk about empath interfaces on the Steelhead. An empath interface is a virtual interface, and it's made up of 2 physical interfaces. This CX755 has 2 empath interfaces, so a total of 4 virtual physical interfaces. Each empath interface has a relay controlling what the behavior of those physical interfaces are. By default, they are in a crossover mode, meaning that any data that's coming into one of these physical interfaces simply crosses over and goes out the other physical interface and out this way. And the same thing happens on this side with this empath interface. What we want to do is turn them into their own physical interfaces, layer 3 interfaces. And in order to do that, we need to flick a few registers inside the hardware. We do this using the SM bus. So first we need to go into the shell of the machine, and you need to go to this file again and add 2 lines. This allows us to send commands over the SM bus. Once you've done that, you'll need to reboot the machine. Now that the machine has booted up, I'm going to go into the GUI of the pfSense. You'll obviously need to set this up. Go over to System, go to Package Manager, and search for a package called shell command or shell cmd and install that. This is just a package that executes shell commands on your behalf upon boot of the machine. Go to Services, you should see shell command there. Click on Add, and you're going to add this particular command. And you want it to be an early shell command, so it does it early on in the execution, or in the boot process I should say. Call this whatever you like. I'm going to call it number 1. Then the next command, I'm going to put sleep 3. I'll explain this in a second. Let's put in a third command. So I've found that if it tries to execute this command and then immediately this command afterwards, the second command will fail. There needs to be a little bit of a gap before it sends that signal. So I'm just putting another command in between that sleeps for 3 seconds. It probably doesn't need to be that long, but 3 seconds is fine for me. So I've saved that now. And before we reboot to test it, I would like to do a very brief test here. If we grab these commands and put it straight into the shell, and you put your ear nice and close to the steelhead, you should hear a very satisfying click when you press enter. Nice. And again with the other command. Now that will work in this particular boot, and if you do a reboot it'll keep working, but if you do a shutdown the relays will just simply go back into the previous state. So that's why we're putting the commands inside the shell command program. Now if you reboot the machine, you should find that you'll hear the relays click a couple of times, and during boot they'll click again and they'll be on. Now you can test this by simply putting a cable between empath, one of the interfaces of empath 0_0 to one of the other interfaces of empath 0_1, and you should get link lights popping up. That means it's worked. We've mounted the Steelhead inside the cabinet and plugged it in. All 6 interfaces are up and link lights are on. Over here on the pfSense dashboard in the top right hand corner, all 6 interfaces are up, full duplex and at 1 gigabit speed. Okay, that's it. We've built our very own pfSense 6-port router. Thanks for watching. If you found this video useful, please hit that like button.